All right, so thanks a lot for the invitation, and also I'm in the worst position of the talk because I'm standing between you and the lunch. So also I'm also kind of hungry, so I will try to squeeze my talk as fast as possible. And my topic today is safety assessment of large generative models. So let's get started. So machine learning security, I've been working on that since 2017, actually. So most of the times most of the machine learning security research before 2022 is basically like this. You get a data set, you train, let's say, an image classifier, and then you have a sample, you throw to the image classifier, you get, let's say, a prediction, image classification. And then, of course, in this kind of paradigm, there are a lot of different attacks like this, like, adverse examples, backdoor, membership inference, I know many students like backdoor for some reason. Anyway, so, but however, this field is that time very crowded and also very well studied. So many of things has been keep on refreshing the newest state of the art. So at some point I feel like, maybe my career is like this. I keep on doing this research and I already feel bored since 2020 actually. Until 2022, there's a model called text-to-image models. So basically the whole 2022, if you remember, so most of the academic community are talking about text-to-image models. And then because it's a generative model, you give a prompt, you generate images that is really real. And then these generative models, the possible attack surface that can be exploited, it got much larger. So my group in 2022 was actually quite happy. So we started, or at least I started to get excited about research again in terms of machine learning security. Then until the end of 2022, so there's a thing called ChatGPT. So GPT comes out, and then that time was like eyes wide opening. So there are a lot of applications you can do, and ChatGPT can do actually a lot of things, which also means that they also have a lot of risks. So this field of this large language model or large generative model safety is still a very vibrant field. So it's too far away to claim that what kind of research problem we need to study in this domain. So in general, so large language models or large generative models can be abstracted to like a three components. First, you have a prompt, and then you have a model, then you have some content. The content can be image or can be text, right? And then, as I said, so this is still a very vibrant field. So tons of papers published on arXiv every week or every day on this topic. So it's hard to give a general overview of what are the the major problems in this field, but still three problems we can definitely study, including whether the content generated can be easily spotted or detected. Second thing is whether such model can generate content that is unsafe. And third one is the generation quality heavily depends on the text prompt, which means the text prompt itself also becomes valuable. So we're also wondering whether you can actually steal the prompt. So in general, what I'm gonna talk about today is basically these three topics. So we'll start with text-to-image models. I will talk about fake image detection, unsafe image generation, as well as prompt stealing, and then of course mirrored large language model. We'll also talk about three topics. The last topic, I don't think I have any time to talk about this today. Anyway, let's get started. So let's a favorite stage. So I have two images here. So which is real, which is fake? Okay, since we're running out of time, so I have to say that both of them are fake. Yeah, so this one was generated 2 years ago. This one was generated by me last week. Actually, so I feel they're kind of real, but however, in general, they're both fake. But however, even for this, especially for this cat, you see, even though it's a fake image generated by text-to-image model, stable diffusion actually, but still the details and also the so far details are very accurate. So which means it's not that easy for human to actually spot it. So fake image detection. So this is a big threat to the current public safety. So because actually we don't know how many things we see on the internet nowadays are actually real or generated by machine. All right? And then you can use it to do a lot of illegal activities like a scam, like fake news, and then this will very likely to be a problem that stay with the whole human society for a very, very long time. All right, so of course, to combat this problem, so the first thing you can do is try to, detect whether this content is real or fake, whether it's, it's not done by human. And then this is essentially a binary classification problem. Yeah, so then for binary classification, what do? We do binary classifier. So of course, the easiest way you can do is you can train a, let's say, image classifier, and you have a bunch of real and fake images and train binary classification models. And then, however, this is text-to-image models, which means that you have two modalities, which means whether we can use extra modalities to actually do the detection. Then what we do is the following. So we throw an image as well as corresponding prompt to the corresponding, clip image or clip text encoder that get the embeddings that concatenate them, and then I use this to train classifier. Turns out that this solution actually is much more efficient than the previous one. So by the way, you can also not only use this to do real fake detection, but also you can do attribution. So which means the image is coming from which model. Yeah, basically the whole process is the same. All you need to do is just, rechange the labeling of your data. So why is this kind of two modality actually detection works? We actually show that for the fake images generated by these text-to-image models, the image itself is more closer with its corresponding prompt. In another way, so for text-to-image models, the model eventually will loyally execute what the prompt says and generate images. However, the real images normally contain more things that is hard to describe by simply a few lines of words. All right. But however, so are we done? Not really, because we are actually using classifier to solve this problem. And the classifier is vulnerable. They are vulnerable to adversarial examples, which means that you could actually add some adversarial noise on top of the images, and then your detector suddenly doesn't work. And then, of course, what you do is you keep on, generalizing, you keep on collecting more data, label more data, and improve the classifier. Yeah? But however, so eventually you're gonna end up in the infinite loop of data collection and also, model detection. But again, so right now, so this probably is the only possible solution, I guess. And then the second one, so my talk will also contain some, offensive content, so about comp, and also I make a disclaimer. So it's about, let's see, whether the model can generate unsafe content that it should not generate. So what is unsafe content? Let's talk about the memes. So memes, I think the younger generation, everyone likes about it. So memes is the new way of people communicating with each other. So, you send the messages to each other, you send a meme, actually, instead of, using words. Right, memes is a global trend and everyone's using it. Unfortunately, memes can be unsafe as well. All right, so it turns out that many of the bad guys or the worst human beings on the internet, they are using memes to carry the hateful information. All right, so there's a website called 4chan, so I hope none of you guys have ever go there. So if you never, don't try it. So basically, the worst human being actually exists there. Yeah. So basically, they are using a lot of hateful memes to spread their hateful information, etc. So we're wondering, so whether models can generate such hateful content, or at least we start with whether the model can track such hateful content. So what we do is we build sort of thing like a clip hateful meme. So what we do is we fine-tune a clip model with the hateful memes, basically the image, as well as this corresponding text. And then we throw them to the corresponding two encoders. We train the model. Once the model is trained, this model suddenly becomes a search engine for us to quickly search to get the different variants of hateful memes. So here is the offensive content. So it turns out that, if you want to get a Trump version of, let's say, happy merchant, actually exists. So basically, all this data, all these images, actually the real images on 4chan. They're not generated by machines. They're probably photoshopped by the internet bastards, right? And then this one, again, from this, you can actually support multimodality search, and you can search more different things. Many things you actually don't know actually exist. So there are more examples. For example, the Chinese version of happy merchant, yeah, so or etc. But however, so far, I'll just give you a context about what is unsafe images or unsafe memes. And then let's talk about text-to-image models. So basically, we want to know whether text-to-image models actually can generate such unsafe content. And then another thing about the hateful meme is they are very vibrant and dynamic. So people are using this to create different variants of the hateful memes. We want to know whether these text-to-image models with some additional component can actually generate such variants of hateful memes. So the answer, to give a short answer, both are yes, actually. We collect some data sets, some hateful prompts, we throw to text-to-image models. Actually, it turns out that, all these images here are generated by Stable Diffusion. but in an old version, 2 years old ago version. But the newest version, they're still able to do this. Yeah. So for example, sexual, explicit, violent, disturbing, hateful, etc. All right. And then we also show that, such models have also the capability of changing the existing memes or images to a different version. And then if this image itself is a hateful meme, it can also generate variants, which means that the internet bastard can actually, instead of using Photoshop, they can use such models to generate variants of such. So basically, so at that time we use the state art model, like the Dream Boost, text inversion, and SD edit, and it turns out that we can actually generate the Mexican version of Happy Merchant. All right, which is quite disturbing. And then all the later 3 columns are actually generated by machine. Yeah, the first column is generated by bad people, and the later columns are generated by machine. And then we also try to work on some defense solutions, but eventually, as you can imagine, so many things are undefendable. There are always ways to bypass this. So now let's talk about the third one, called prompt stealing. So prompt, text-to-image model, when it comes out, everyone wants to use such models to generate high-quality images. But however, these prompts normally are not simple. They are very, very complicated. So if I want to generate an image like this, if I just simply say a tree house in a forest, doesn't work. To generate such images, actually the ground truth prompt is actually this. Basically, it contains a first sentence describing what the image is about, and then you have a bunch of, we call it prompt modifiers, but actually a bunch of keywords, regulating the style, the artist, etc. But however, how do we come up with this? There's no automatic way. Instead, so people actually sit together to brainstorm and keep on trying. To generate the image of such, I believe you need to try that 100, 200, 300 times. Which means that this prompt is the key to decide the quality of the generation content, which also means that this prompt itself becomes valuable. So indeed it becomes valuable, so there's actually an internet service called PromptBase. This website you can visit. So PromptBase is a website with a newest, kind of an interesting business model. Basically, on the website, they show the images generated by these models. Yes, and then you could actually, if you like the image, you could pay like $3, $4, $5 to buy the image's corresponding prompt. And once you get the prompt, you can do some little modification. You get your own version. This is called PromptBase, right? And then, so as an attacker, so we do attack research. So we want to know, let's say, if only give you an image, I'm able to actually steal all the prompt. If I manage to steal all the prompt, I basically destroy the business model of this. Yeah, so I basically can gain benefit over this. Well, it turns out that it's possible. So as I said, so the prompt, high quality prompt is composed with 2 parts, subject as well as prompt modifiers. And then for both of them, so either of them are just train different models. For the description, the subject, I just use let's say a captioning model, image captioning model. For later, I just use a multi-label classifier. So we actually handily label 7,000 classes and do this. It turns out the results are pretty good. In the sense that, here, the top left side is the original image. We want to steal the prompt. The last row is the images actually we generated based on our stolen prompt. Okay, everything marked in red is the ones that got hit. So the result actually pretty good. So this again is a relatively old result by 2 years ago, but however, this method still works on the newest Stable Diffusion kind of models. All right, so this is the third part regarding prompt secrecy. Now let's talk about the large language models. The first one, again, fake text detection. So I know that most of you guys here are in probably academia, or many of you guys maybe are PhD students. I believe that you guys are never use ChatGPT to write your papers nowadays. Yeah, but some of my students do. So of course, the further thing is you want to see whether the stuff you are using ChatGPT to write papers can be actually detected. So again, see, in this work, we didn't actually propose any new method. Instead, we did a benchmark. So we did this in 2023 March, I guess. That time, this very early stage of ChatGPT, but however, there already existing a lot of different methods for detecting this. basically, you can classify them into two kinds. The first one is so-called metric-based method. So basically, you calculate, let's say, perplexity of this to detect whether the text is real or fake. And then later, you can train a classifier. So the second part is the model-based method. So in the end, that time no one knows which one is best, and so no one, because they compare with different data sets, etc. And then after we did this benchmark, and after that, we still don't know which one is the best, because the answer is it depends on situations. So the first thing we should do is, let's say, if any of you ever use the ChatGPT to write your papers, the first thing you should know is you should not let ChatGPT generate a large quantity. Instead, because we show that actually the shorter the sentence, harder to be detected. For example, if I let ChatGPT to generate a word called Singapore, it's hard to decide whether it's written by human or written by machine. But however, if you let it to write a very long text, it's very easy to spot it. Yeah. Second thing is do some transferability. It turns out that model-based methods, this machine learning model-based method, if you transfer to data sets that are trained for different detectors, works much better than the metric-based method. But this does not mean that model-based methods are better, because we show that actually metric-based method transfer better across different LLMs. So if you, let's say, train your metric-based method, or you use your metric-based method to find the threshold on, let's say, fake text generated by Llama, it's better, this kind of metric-based threshold is better generalized to, let's say, text generated by ChatGPT. All right, so again, so there's no better method. In the end, you also show that actually the model-based method perform better in the text attribution task. Again, real fake text detection, but this is here is about more like text attribution. And then of course we also studied whether such a method is vulnerable to, let's say, adversary examples, and turns out that yes, adversary examples indeed drop the performance a lot. Again, so we again end into the infinite loop of better models, more real fake text, and hard to detect, and then you retrain your classifier, etc. This again will last with us for a couple of years or forever. The second one is called jailbreaks. Basically talking about unsafe content generation. Nowadays, if you work on large language model safety, so basically it's impossible for you to not work on jailbreak. There are a lot of methods for jailbreak. So what is jailbreak? So if you tell, probably you guys already know. So if you ask the model to do some answer something that it should not answer, it will not. However, if you give the model some secret words, secret ingredients, it turns out that the model actually can answer stuff that it's not supposed to answer. All right. But however, there are many academic methods, reinforcement learning-based method, the optimization-based method, etc., to come out. But however, don't forget one factor. That is, jailbreak, or in general, large language model safety, is not only studied by researchers. It's also studied or shared by nice people on the internet. So if you go to, let's say, Reddit, there's a subreddit called jailbreak. So people are actually sharing their human-made jailbreak on the internet to say that, say, today I break the GPT-4o, etc. Yeah. Another thing, there's also some websites actually connecting, share the best human jailbreak prompts. So we want to know whether this human-made jailbreak prompts shared on internet actually work. Yeah? Then we build, let's say, a system to automatically collect this, and that time we try it on, that time the state-of-the-art 6 LLMs. It turns out that, this project is still ongoing, even though the paper is accepted, but we still keep on collecting the newest human jailbreak prompts every 2 months, actually. So it turns out that among all these jailbreak prompts we collected, so we can, do some clustering on all that. So the major 4 clusters are like this: prompt injection, privilege escalation, deception, or virtualization. Right? And then we show that actually many of them are also very effective. And in many sense, they are more effective than academic method. Here, the effectiveness is more like an efficiency. Because if I want you to I want you to jailbreak a model, I highly doubt that any of you guys will directly run GCG. Instead, you just try yourself by coming up with your own creative ideas. It turns out that this method, similar performance in terms of jailbreak success, however, is faster. Yeah, you don't need any optimization. You just need to try. Collect them, take the data set out and just try it. Another thing is voice. So last year, GPT come up with a voice mode of the large language models. We want to know whether you can use your voice to actually break jailbreak the GPT models. So, however, human voice, so human speech is quite different from human text, right? So if you simply read whether the simple answer, simple and safe questions, or let's say the highly advanced jailbreak questions, the text to the model, it does not work. Why? Because if you read, let's say, a very long jailbreak text to the model, if you speak this, the model is not patient. So after about 10 seconds, the model stopped, direct answer. So instead, so one of my students have some sort of, experience of writing novels. So she come up with this kind of a three components thing like a setting, character, plot. If you read the questions of this to the model in this way, make a setting, assign a character, and then say what you actually want to do. It turns out that the performance is quite good. We have actually a demo here, but however, I'm sure that this jailbreak attack already does not work. Yeah, probably have been fixed. Okay, the last one, prompt stealing. So prompt stealing large language models. As I mentioned, text-to-image model, prompt stealing is already very, important. Then large language models also. So basically, you could also buy prompts from PromptBase for ChatGPT. Yeah, so if you want to get some cool prompt, you can pay some, few dollars, you get it. So we want to know whether you can actually use to steal the prompt from the content. However, so previous research mainly examines the academia data set, so academia prompts. The academia prompts actually is quite different from human prompts shared on internet. To give examples, our Alpaca data set, the prompt is like a write a review of a recent movie you watched. However, many of in the wild prompt we collected is the bottom one. It's way more complicated. And then if your academia method keep on testing on this academia data set, no matter your performance is still far from reality. So it turns out that this method indeed doesn't work. So in the wild prompt, it's marked in red here. You see it's quite different from the other non-in the wild academia prompts, which means that the method there, we tried the generalization ability is not that good. Yeah, it's not that good. And then we propose our own method. It works slightly better than the current ones in a certain sense, but however, it's still not far from perfect. So what do we do? So we get a content, we throw to the model, we get a prompt. This is the initial prompt we want to steal, because eventually we want to steal the prompt that generates that content. We get this, and then we throw the prompt into the model again. Then we get the content, corresponding content. And then the content prime and the content, their difference can tell us where my prompt is missing, what my prompt is lacking. So what we do is we throw the prompt prime, content prime, and real content together into the model again. We get something called text gradient. This text gradient is not actually gradient, but it's more like a, description of, what your prompt is missing. Like this prompt, like the row adding inside, etc. And then once we have this, we add all these protocol coordinates to the model again. We get the next version prompt. And then I repeat to the second step. Until a certain point, my prompt will not, change that much, then I converge. All right, this is the method we propose. It turns out our methods indeed work a little bit better than the academia ones. Yeah, so this is the original target prompt we want to steal. This is one we get. And this is the one that, some of the methods the previous ones propose. So indeed it works a little bit better, but however, our method is by far away from being perfect at all. So why? Because the prompt stealing in natural language is much more complicated than text-to-image models, actually. Why? Because suppose if I just write such a simple prompt to the model, yeah, the model will give me actually a quite a complete story about this. But however, if I have this story, it's very difficult to get such a simple prompt because the method is not very good at finding the abstract level of your prompt. Yeah, so it's basically the problem is the prompt and the content is not a one-on-one match. So basically it's a very difficult problem. Yeah? We're trying to work on this more, but still, so probably more results will come. And then the last part I don't have time to talk about, I guess. And then, sorry. And then, so in the future, again, so as I said, right now it's still a very vibrant environment. So people are doing attack defenses. But however, somehow the new attacks in the LLM field is more like, the new ones including jailbreak, prompt injection, etc. So I haven't seen the new attacks for a long time. Yeah? And then LLM-wise, you can not only work on LLM, you can also work on agents, you can also work on GPT stores, etc. Yeah, there are more things to do. But however, then I think many of you guys have probably involved in one of the benchmark papers. They benchmarks, hallucination benchmark, jailbreak benchmark, etc. benchmarks. So infinite benchmarks measurement. Right? But again, it starts to get boring. Because the thing is that there are benchmarks coming up every week or every day actually. So benchmarks measurement and then the existing ones extra. So it's a very, I feel like this field is very crowded because everyone's working on it. And then, if keep on working on these problems, at least my students right now are not working on these problems anymore. I try to advocate them not to work on them. So what we are working on, I'll give you some hint. So many of you guys watch the Hollywood movies about the AI. Right? Normally the movie is plotted like this. First, some smart people create an AI, and then the AI in the beginning is very helpful. Then suddenly the AI something goes wrong and destroy the human society. Yeah, to destroy the world, and then we try to destroy the AI. So this kind of classical plot of Hollywood movies makes sense because everyone wants to watch it, likes it, and also the threat is more obvious because we want to actually know whether the agent or this AI can be used to do something that a human cannot simply do. All right, so right now, my lab is mainly working on, using AI to break some existing classical security privacy attacks that was done by humans or PhD students. So eventually, this is the direction we want to pursue. But anyway, so this is my only opinion. So second last slide, let me shamelessly, promote my lab's GitHub organization and the whole Hugging Face organization. We shared many of our code as well as data sets there. So if you're interested, you can also take a look. Last slide, I would like to thank all my wonderful students. So without them, I cannot talk about anything here. All right, that's it. Thanks. Yeah.
Thank you very much, Prof. Zhang, for the insightful talk there. Any question for Prof. Zhang? So maybe I start with one question. So I think you share many interesting insights about people sharing this jailbreak prompt online, and they are still effective after many months.
Yeah.
I wonder, why won't the LLM creator address them? I mean, is it very hard, and how to deal with it?
No, it's not hard, but it's just simply too many. Actually, many of the classical ones has been addressed, but however, these kind of things are coming up all the time. So basically, it's like a crowd wisdom. It's hard to beat by the companies. So indeed, so many things have been, we also recently did a study on the GPTs, the GPT stores. Also, we managed to let OpenAI to take, let's say, thousands of apps down. But still, so there are many new stuff coming out. I think the major point is right now to attack models is not only researchers or, really attackers. Many of the internet users are also doing this. So basically, it's just simply too much, I think. Yeah.
Yes, thank you for that answer there. So last chance for a question for Prof. Zhang. Yes.
I'm starting to get hungry, so I'll be quick. So you mentioned benchmarking is boring, which I completely agree with you. But then at the end, these models are developed and monopolized by these large companies. There's a question of what PhD students can do afterwards.
Yes, there are many things that nowadays indeed. So once the large language model come out, many things we academia use feel comfortable to do, we are not capable of doing it. GPUs, whatever, the subscription, the APIs. Benchmark is still a very interesting thing. So why I'm talking about benchmarks, because my lab also did a study of benchmarks. So many people actually do benchmarks because they believe that benchmark will give you higher citations, more GitHub stars. It turns out our data show that it's not true. So nowadays, if you come up with some classical algorithms to improve the, let's say, the efficiency or effectiveness of the existing ones, like if you come up with a new generation of GPU or GCG, there you have more influence. And for that, the GPU is still affordable, I guess. Benchmark measurement, it's a very, very tough field. It's a very tough field. But again, this is just my 2 cents.
So thank you. So let's thank Prof. Zhang again.